Hiya, Professor.
Good morning, alien.
You know what? I just flew over your solar system, and I noticed there are a lot of objects flying around in the orbit of your planet. What are they?
Yes, I can. We have lots of satellites and space stations that are used to provide Earth with valuable information. We use weather satellites for our weather forecasts, observation satellites to learn more about space, and there are so many other important satellites.
No. I meant these objects that just float around.
Oh, you probably mean space debris. It is a bit of an awkward topic for us. Space debris is pieces of junk in space. They fly at speeds of up to 8 kilometers per second, which is equal to 30,000 kilometers per hour. And if they collide with another object in space, they can break or fragment that other object, creating even more space debris. And you know what? Most of the objects are just the size of a screw, but any size can cause major damage.
What? That sounds horrible. I've heard of space debris, but I've never seen it. How did it get up there? Surely you wouldn't want it there, would you? Our solar system does not have any of that.
That is a good question. Natural debris has always been in our orbit. This includes pieces of asteroids, meteoroids, and comets. Artificial or man-made debris first appeared in our orbit directly after our first satellite launched. The problem was that nobody had predicted it. The main reason there is space debris in our orbit is because rocket stages and other mission-related debris is left in orbit unsupervised, and nobody has tried to bring it back to Earth again. The dangerous thing is that this debris then creates even more debris through colliding with other still functional satellites.
Really? But why?
Let's take this one as our example, Apollo 12's third stage. Well, I will skip the part with the launch. After the launch, the rocket kept on zooming higher and higher. The first thing that was disposed of was its first rocket stage. Luckily, the first two stages normally land in the Pacific Ocean. This means they do not create space debris. However, they do cause quite a lot of different problems down there on Earth.
Why did they dispose of the first rocket stages? Don't you reuse them or what?
Back in 1969, we did not have the technology to bring rocket parts safely back to Earth. During the flight, they discarded the rocket stages that no longer contain fuel to make the rocket lighter. This is done to not waste fuel as the rocket escapes Earth's gravity. And to answer your other question, we only paid notice to the waste of the missions approximately 50 years after our first moon landing. When the third stage is finally used up, it is disposed of as well. But when we follow the third stage, it is designed to be cast into a heliocentric orbit, an orbit around the Sun. At least, that is what we intended. Nowadays we know that through strange coincidence, Earth can recapture third rocket stages so they then orbit Earth.
What? You cast junk into the heliocentric orbit, but that does not always work, and now it is orbiting Earth? You are playing a dangerous game here.
Yes. Fortunately, Apollo 12 was the only third stage rocket that is now orbiting Earth. Though it may seem strange, we first thought it was an asteroid, but then we discovered that it was painted in the paint NASA used to paint the Saturn V vehicles.
Okay, but how do you protect your satellites then?
Normally, there is a system that warns us if space debris is approaching, but it only works when the tracking data is accurate. If it is not, we do not know where the debris is, so we cannot always avoid it. There are a lot of steps involved in performing these debris avoidance maneuvers. This means they are extremely time-consuming and require a lot of expertise for each step.
Sounds smart. And Do these maneuvers work?
While there are many accidents that can be prevented, there are, however, still many accidents that do occur. One of them, for example, would be China's ASAT test. ASAT stands for anti-satellite. These tests work by destroying one of your satellites with missiles. During their anti-satellite test, China destroyed their still functional weather satellite Fengyun 1C. This accident created 3,428 pieces of trackable debris and many more non-trackable. Fengyun 1C is recorded as the biggest breakup in history. It is said that it increased the amount of space debris in our orbit by 10%.
Crazy! That's a lot. Do you have another example?
Another event like this would be the Iridium-Cosmos collision. These two satellites, one of them not functional and the other still active, collided on the 10th February 2009. They are the second and fourth biggest recorded collisions. They collided right over Siberia at a speed of approximately 10 kilometers per second.
Scary! If all that happens in your orbit, aren't you worried or what?
It is scary, especially if you know that the total mass of all objects in Earth's orbit are estimated to weigh a little more than 9,200 tons. This would be approximately 2,000 elephants. Another interesting fact is that there are 64 fragmentation events in our orbit every year. The biggest culprits for this amount of space debris are the USA, Russia, and China. When two objects collide, they form a great cloud of debris. Afterwards, the cloud spreads out, surrounding Earth with a few hundred pieces of debris that are jeopardizing all other missions. This can cause a chain reaction called Kessler syndrome. You see how this problem perpetuates?
And have you thought of a solution yet?
We have already created a few designs. ClearSpace, for example, is a pioneering initiative funded by the European Space Agency to find a solution to space debris. The problem is that we have to catch an object in microgravity at high speed with no friction to not alter its trajectory. Their approach is to try to catch the debris with a grappler or net and then sending it into our atmosphere where it will then burn up. There are a few other ideas as well, like Japan's solution of shooting an electrified tether cable at a piece of debris and zapping it to slow it down, and then send it into the atmosphere to burn up. One of the older solutions is to disintegrate the debris with a laser, though this has never been proven to work.
Aha! So you have many possible ideas, but you have not really tried them out yet, right? It's quite obvious which one is the best solution. We also are using it to keep our space clean.
We would be very grateful if your species could help us solve the problem. What about we go to my study and see what your solution is?
Uh-oh! My mom just called. I have to get home really quickly. Bye! See ya! Ciao, ciao!
Oh man! Now we must find our own solution, I guess. We better find it soon. Let's get cracking!